Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will discuss important past paper question on DC circuits from Oxford Physics Admission Test 2020. For this question, simply we need to find out which ammeter gives the highest reading, and we have 5 ammeters A, B, C, D and E. Let's say current passing through ammeter A, this is IA, and current passing through ammeter B, let's say this is IB, and current passing through ammeter C, let's say this is IC, and current passing through ammeter D, this is ID, and current passing through ammeter E, let's say this is IE. If we look at ammeter A and ammeter B and C, we can simply write down that current passing through ammeter A means IA, this is equal to IB plus IC. Or we can simply say that IA is greater than IB and IA is also greater than IC. So B and C, these are not possible options because we need to find out which ammeter gives the highest reading, as A give higher reading than B and C, so B and C are not possible answers. So we can eliminate these two. We need to look at A, D and E. Our answer can be A, D or E. Let's try to connect voltmeters first of all. Let's say we connect voltmeter across this branch. Let's say this voltmeter is V1. We connect here. And we connect another voltmeter. Let's say we connect this voltmeter across second branch, and let's say this is our voltmeter 2. We can simply say it is V2. So we can connect here. So this is voltmeter 2. Now let's connect another voltmeter, and that is across the third branch. We can say that this is third voltmeter, and this is connected here. Now if you look at all these voltmeters, you see this point is common with other points, or simply we can combine all these points. So this is the same point, means the potential of these points is the same. Now if you look at this side, the potential of all these points is also the same. So it means the reading on voltmeter is the same because these voltmeters simply tells you potential difference. So we can say that in this case V1 is equal to V2 and this is equal to V3. We can write down. The next thing what we need to understand is that as V is equal to I times R, if resistance is lower, current will be higher. Now simply we need to find out the total resistance of each branch, and then we need to compare, and the branch with the lowest resistance will have the highest current. First of all, let's try to find out what is the total resistance of this branch. Let's say this is branch 1, we can also write down here, and let's say this is second branch, and let's say this one is the third branch. The resistance of branch 1, simply we can calculate R total. This will be equal to resistance of this resistor plus the total resistance of these two resistors, and these two resistors, they are connected in parallel, so simply we need to multiply their resistance and we need to divide by sum of their resistance. So this is how we can find the total resistance of branch 1. In this case, total resistance is equal to 1.67 times R. Now let's try to find out total resistance of second branch. In second branch we have only 2 resistors and they are connected in series. So our total in this case simply is equal to R plus R by 3, and this is our final answer. Now the last branch, means the third branch, our total, there is only one resistor, that is equal to 1.4 R. As second branch has the lowest resistance, so ID is the greatest, mean this current is the highest. So ID in this case will be greater than IE, and IE will be greater than IA. So our final answer is D. So this is our final answer.